Chapters 1 and 2 review. From set below, list all numbers that are A, natural numbers. Our natural numbers are counting numbers. So looking at this list, the only counting number we have here would be square root of 100, which is the same thing as 10. Whole numbers, we have 0 and the square root of 100. Integers. Our integers would be all the numbers that can be written as that would be either positive and negative whole numbers, natural numbers as well included. So we have -9, 0, and the square root of 100. Rational numbers now would be all the numbers that can be written as fractions. So we have -9, -4/5, 0, 0.25, just 25/100, 9.2, 92/10, or 9 and 2/10, and the square root of 100. Irrational numbers. There's just one irrational number, that would be square root of 3. This is a number that cannot be written as a fraction. Simplify, do not leave negative exponents. We're using the laws of indices. So we're going to apply the power of 2 to each item inside the brackets. So we have 3 to the power of 2, x to the power of 4 times 2, power raised to another power, we multiply. 4 2s are 8, y raised to the power of 7 times 2, 7 2s are 14, 12 to the power of 2, x to the power of 1 times 2 is x to the power of 2, y to the power of -5 times 2 is y to the power of -10. 3 times 3 is 9. 3 squared, 9. We have x to the top and x to the bottom. So we have a quotient. The quotient rule tells us to subtract our powers. So we have x to the power of 8 subtracting 2. Quotient rule again for the y. We have y to the power of 14 subtracting -10. And that's all over 12 squared, which is 144. 144 and 9 both have 3 in common. So we can factor out a 3 from both of them. So factoring out 3 from the 9, we're left with 3. So we can cancel divided by 3, simplifying 144 divided by 3 would be 48. Now we have our x. 8 subtract 2 is 6. Our y. 14, negative times a negative is going to give us a positive 10. 14 plus 10 is going to give us 24. Remember, yeah, 14 subtract -10, which is 14. Negative times a negative is a positive. And 14 plus 10 is 20. Check that 144 divided by 3. We can cancel it because 9 can actually go into 144. So let's fix that. So 3 can go into 3 ones. So we're left with x to the power of 6, y to the power of 24, and 3 can go into 48 16 times. I did not notice the 9 and the 144 immediately. So dividing, simplifying by 3, dividing both by 3 first, and then by another 3. So my final answer is x to the power of 6, y to the power of 24 over 16. Next, we have 2a squared, y to the power of negative 3, where all raised to the power of 3. 5a to the power of negative 1, y to the power of negative 2, all raised to the power of negative 2. So let's begin. So we're going to get rid of the brackets here. So we have 2 to the power of 3, a to the power of 2 times 3, which is 6, y to the power of negative 3 times 3, which is y to the power of negative 9. Now we have all of this raised to the power of negative 2. So we're going to change that. We're going to now take the reciprocal. When we take the reciprocal, our power now becomes positive 5a to the power of negative 1, y negative 2 raised to the power of 2. We now have 2 to the power of 3, which is 8 to the power of 6, and y to the power of negative 9. Let's now expand our bracket at the bottom. We have 5 squared. A to the power of negative 1 times 2 gives us a to the power of negative 2. Y to the power of negative 2 times 2 would give us y to the power of negative 4. Now, 8. Let's see what that is. We have a negative 9 to the top and negative 4 to the bottom. Now, first, let's deal with the 8s. I have a to the power of 6 to the top, a to the power of negative 2. I'm going to move my variable with the lowest power, moving the variable with the lowest power in this case. So I'm going to now move the a to the negative 2 to the top. So again, it's a quotient. So I now have a to the power of 6. I have negative 2. It's a quotient, so it's now negative times negative 2. We're subtracting if we have a quotient. 5 squared gives us 25. And actually look into this. Yeah, let's do it this way. I'm going to move my lowest power again. So I have y to the power of negative 9, y to the power of negative 4. Negative 9 is smaller than negative 4. So I'm going to leave my negative y to the negative right where it is. And I'm going to subtract the negative 9. This is now equal to 8 over 25. 8 to the power of 6, subtract negative 2. So that's 6 plus 2, giving us 8. 25y, negative 4 plus 9, giving us positive 5. Let's just make sure we got ours. We have 6, subtracting negative 2. Negative times a negative is a positive. That gives us 8. And then we have y. Let's get rid of the y. The y. We have negative 4, subtracting negative 9. We have negative 4. Negative times a negative gives us a positive 9. signs are different. So we're going to take the sign of the biggest absolute number, which is 9. 9 is positive, and we're going to subtract. 9 take away 4 gives us 5. So my final answer is 8. 8, 8 to the power of 8, 25 y to the power of 9. This here is just in case we need clarification. Syllabus. Evaluate, show all working. We have the square root of negative 5 all the way to the power of 2 plus 2 plus 3 squared divided by the absolute value of 24 divided by 2 multiplied by 6 subtracting 5. Let's deal with the numerator first. So we have the square root of negative 5 squared. It's negative 5 times negative 5, giving us positive 25 plus 2 and 3 squared plus 3 squared, which is 9. 3 times 3. Next, bottom. The rule says that if we have multiplication and division, we go from left to right. So we're now going to deal with the first two, 24 divided by 2, which is 12, times 6, subtract 5. Twenty-five plus 2 is 27. Plus 9. The absolute value, 12 times 6 is 72. Subtract 5. We have 27 plus 9, giving us 36. And 72, subtracting 5, giving us 67. There's nothing common to 36 and 67, so our problem is complete. Six subtracts 7 open bracket, negative 2 squared minus open bracket 2 times 3 squared minus 6 divided by square root of 9, close bracket, close bracket. So we're going to work from inside out. So this is equal to, we bring down 6. We cannot touch the 7 yet, as yet. We're going to leave the 7 alone. Negative. Now, the negative is not being squared, just the 2. So 2 squared is 4. We have our negative, open bracket, 2 times 3 squared, which is 9, subtracting 6, divided by the square root of 9, which is 3. 6, bring down negative 7, bring down our negative 4. 2 times 9 is 18, subtracting 6 divided by 3, which is 2. 6, bring down the negative 7, bring down the negative 4. 18 subtract 2, which is 16. We can expand the brackets by using the distributive property, or we can simplify what's inside. I'm going to go ahead with simplifying what's inside. Negative 4 plus negative 16 gives us negative 20. Signs are the same, so we just add the sign, add and keep the sign. Now I can get rid of this bracket. Negative 7 times negative 20 is going to give me a positive 140. 6 plus 140 is 146. 5 plus 64 divided by negative 8, subtracting negative 31. divided by -4, subtracting 3. Dealing with angle first. Cannot touch the fibers yet because I have a division in here, so I need to deal with my division first. I have 5. Positive 64 divided by -8. A positive divided by a negative will give me a negative. 64 divided by 8 gives me 8. So positive 64 divided by -8 is -8. And I have -1 times -31, giving me a positive 31. Signs are the same in the bottom, so I'm going to keep my sign and just add 4 plus 3, giving me 7. 5 subtract 8 is -3 plus 31. Signs are different. Oh, sorry, over 7, -7. Signs are different. So I'm going to take the sign of the biggest absolute number, which is 31. That's positive. And I'm going to subtract 31, take away 3 is 28, divided by -7. 28 divided by -7 is equal to -4. Perform the calculation indicated. Express answers in scientific notation. 1.8 multiplied by 10 to the power of -3 multiplied by 4.0 times 10 to the power of 8. We want to get our decimal values and multiply them together. So we have 1.8 times 4.0. We're going to multiply that by the powers of 10. 10 to the power of -3 times 10 to the power of 8. 1.8 times 4 is equal to 7.2. And we're multiplying that by 10. Bases are the same, so we're going to add the powers. -3 plus 8, giving us a positive 5. (3,000) times 0.08 divided by 0.012. 3,000 is the same thing as 3 times 10. 1, 2, 3, 4 to the power of 4, multiplied by 8 times 10. 1, 2 to the power of -2, divided by 1.2 times 10 to the power of 1, 2, -2. Notice that when I move my decimal point towards the left, my powers were positive. When I moved it towards the right, my power is negative. Now I'm going to take my decimal numbers 3 and 8, multiply them together. 3 times 8. I can do it immediately, but I'm just going to set it up. Times 10 to the power of 4 times 10 to the power of -2 divided by 1.2 times 10 to the power of -2. This is equal 224 times 10 to the power of 4 subtract 2 is going to give me 2 positive 2 divided by 1.2 times 10 to the power of negative 2. 24 divided by 1.2 is equal to 20. And we have, this is being multiplied by 10 to the power of 2. We have a quotient, so we're going to subtract the powers. Subtracting negative 2. And this is equal to 20 times 10 to the power of 4. 2 plus 4, 2 is 4. But notice that 20 is not in scientific notation, so we need to move that decimal point. We're going to move it once to give us 2.0. Because we moved it once, we're now going to add the power of 1. So it is 2 times 10 to the power of 5. Because we wanted to show our working with all the steps. But of course, you can check your answer by multiplying 3,000 times 0.08, giving me 240. Just checking out. This is just for check. So 3,000 times 0.08 will give us 240 divided by 0.02. And that is equal to 20,000. And we need to decimal points 4 times. So there is a mistake in my problem. So it's the mistake is right here. And multiply by 3,000, that's 30,000. So let's try that again. 30,000 multiplied by 0.08, giving us 2,400, divided by 0.012, which is equal to 200,000. So we have 1, 2, let's just fix that to make sure that we check properly, that we get the correct solution. So that's 200,000. So moving my decimal point, we have 1, 2, 3, 4, 5. So my answer is correct. So again, you can always check by using your calculator to find the solution as well. Simplify. We have 8, 9m squared plus 4, 7m squared minus m plus. So we're going to go work from inside, come out. So we have 8 bracket 9m squared plus 4, open bracket, 7m squared. Dealing with this, we're going to now multiply out this bracket using the distributive property. If there's no number here and you need a number, you can always put 1. So we have negative 1 times m giving us negative 1m. Negative 1 times positive m squared giving us negative m squared. Giving us negative m squared. So we would have gotten rid of this bracket, so we would just 2. Bringing down the 8, the 9 squared, plus 4. We're going to simplify inside. We have like terms, 7m squared, subtracting 1m squared, giving us 6m squared minus m. bringing down the 8, 9m squared. And we're going to now multiply using the distributive property. Positive 4 times positive 6m squared, giving us positive 24m squared. Positive 4 times negative m, giving us negative 4m. We can simplify inside the brackets. 9m plus 9m squared plus 24m squared is 33m squared. Subtract 4m, multiplying out the brackets. 8 times 33m squared gives us 264m squared. 8 times negative 4m, negative 32m. To simplify, so we're going to get rid of all of our brackets. 5 times x, 5x. 5 times negative 9, negative 45. Negative x times x, negative x squared. Negative x times 13, positive 13, negative 13x. Positive 18 times x squared, positive 18x squared. Positive 18 times 5, giving us a positive 90. Collecting like terms, we have 5x subtracting 13x, negative 45 plus 90, negative x squared plus 18x squared. Make sure that everything is accounted for. The 5x, negative 45, negative x squared, negative 13x, positive 18x squared, positive 90. Once we've accounted for everything, we can go ahead and simplify, continue to simplify. 5x subtracting 13x gives us negative 8x. Negative 45 plus 90, giving us a positive 45. Negative x squared plus 18x squared, giving us a positive 17x squared. We have fractions involved in this case, so we need to find the lowest common denominator of our denominators, which is 5 and 4. Lowest common denominator would be 20. So we're going to multiply each term by the 20 to get rid of our denominator. Not to get rid of it. Yeah, actually to get rid of it, to get rid of our denominator. So we have 20 times 20 times 20 times 20. So that we can get rid of it. 5 multiplied once, 5 120, 4 times a squared, giving us 4a squared plus 7b times 20, giving us 140b. 4 through into 4 ones, 4 through into 20. 4 ones, 4 through into 20. 5 times, giving us negative 5a squared, negative 16 times 20, 16 times 20, which is equal to 320, negative 1620, negative 1620, negative 320, sorry, negative 320. Guess what? There is no equal sign, so I cannot get rid of the denominators. My denominator would be 20, but I don't need it for my b's. So let's redo this problem. Let's first collect our like terms. So we have 1 over 5a squared. Let's put the a squared on the top, a squared over 5, subtracting a squared over 4, plus 7b, subtracting 16b. It's better. If we have the equals to sign and equal to sign, we would have been able to cancel out our denominators, but we cannot do that. But we want to find the LCD of 5 and 4, which is 20. And we're going to write an equivalent fraction. So this is now 20. I multiply this by 4, so I multiply this by 4, giving me 4a squared. Multiply this by 5, giving me negative 5a squared. Dealing with my b's, I have 7b subtracting 16b, giving me a negative 9b. I have 4a squared subtracting 5a squared, which is a squared over 20, subtracting 9b. Now, if we want to write it as one fraction, we would have had the 9 times 20, 180b, a squared minus 180b. We don't need to. We simplified it. What do I? Now let's make it to one fraction. So I now have, I'm going to multiply by the 20 here. So I now have a squared minus, I'm going to multiply the 20 by the 9, giving us 180b over 20. So I could have actually left it and just put 20 in my denominator and simplify. No problem. So we have a squared minus 180b over 20, writing it as one fraction. So that is in its simplest form. Evaluate the expression for the given values. We have s equals 1 over 2, where a is 2, b is 3, c is 5, and we have a plus b plus c. So we have s is equal to 1/2 a, 2, b, 3, and c, 5. So we have s is equal to 1 over 2. 2 plus 3 is 5. 5 plus 5 is 10. So this is multiplied by 10. Moving on to 2 ones. 2 can go on to 10 5 times. Therefore, s is equal to 5. The square root of b squared minus 4ac when b is equal to 6, a is equal to 7, c is equal to negative 1. So we're evaluating again. So replacing the b with 6, we have 6 squared, subtracting 4 times a times c. This is equal to 6 squared, which is 36. Negative 4 times 7 is negative 28. Negative 28 times negative 1 is positive 28. We have a square root of 36 plus 28, which is equal to 64. The square root of 64 is 8. Solve each of the following, show all working. 2, open bracket, x minus 3, expanding brackets, 2 times x is 2x. 2 times negative 3, negative 6, subtracting 17, which is equal to 13. Negative 3 times x, positive 3x. Negative 3 times positive 2, negative 6. Simplifying both sides, 2x. Negative 6 plus negative 17 is negative 23. 13 subtract 6, positive 7 plus 3x. Getting variables on one side, constants on the opposite. I'm going to now get rid of my 2x, take my 2x to the next side. So I have my 3x, I'm going to bring my 3x down, subtracting 2x from both sides. The 2x will leave, but give us 0 on this, on the right, on the left, and we have 2x here. Leaving my negative 23, subtracting 27 from both sides now. We have negative 23, subtract 7, 3x, subtract 2. 23, signs are the same, so we're going to keep the sign. 23 plus 7 is 30, so that's negative 30. 3x take away 2x gives us 1x. Therefore, x is equal to negative 30. Here we could have done our subtractions if we needed to. Subtract 7 from both sides, subtract 7 from both sides, subtract 2x from both sides, subtract 2x from both sides. And we would still end up with negative 23 subtracting the 7 and 3x subtracting 2x. This will go along with this. Negative 1/3 plus 1/5 times 5 minus 3x greater than or equal to 1/3 x plus 6/5. We want to definitely get rid of our denominators. So we want the LCD. Our LCD is 15. 3 and 5 would be 15. Multiplying each term by the 15. We can go into 3 ones. 3 1 to 15, 5 times. 5 times negative 1 is negative 5. 5 1 to 5 ones. 5 1 to 15, 3 times. So we have positive 3 times 5, giving us a positive 15. Actually, let's just bring the brackets down. And then expand it, which is greater than or equal to 3 can go to 3 ones, 3 can go to 15, 5 times. 5 times x is 5x. 5 can go to 5 ones, 5 can go to 15, 3 times. 6 times 3 is 18. Bringing down the negative 5, expanding the brackets, we have positive 3 times 5, positive 15, positive 5 times negative 3, giving us negative 9x, which is greater than or equal to 5x plus 18. Collecting like terms, simplifying first on the left. Negative 5 plus 15 is positive 10, subtracting negative 9x, which is greater than or equal to 5x plus 18. Keeping all my variables on one side, constants on the other, I have 10 subtract 18, which is greater than or equal to 5x plus 9x. 10 subtract 18 is equal to negative 8, which is greater than or equal to 5x plus 9x is going to give me 14x. Dividing both sides by 14. I get that x is less than or equal to negative 8 over 14. Now I want to represent this on the number line. So I'm going to put in a few values. So I have negative 9 over 14, negative 8 over 14, negative 7 over 14. Now I want x is less than or equal to. So I'm going to go to negative 8 over 14 because it's less than or equal to. I'm going to now shade in the circle. It's less than, so I'm going to go towards the left. My arrow is going to go towards the left. We could also have done it to the top and show the same result. Twelve is less than or equal to 4x plus 4, which is less than or equal to 24. A compound inequality, so we're going to get rid of this positive 4 and subtracting 4. We now have 12 subtract 4, which is 8, less than or equal to 4x, which is less than or equal to 20. Dividing to get rid of the 4. So I divide throughout by the 4. 8 divided by 4 is 2. Less than or equal to x, which is less than or equal to 20 divided by 4, which is 5. So x is greater than or equal to positive 2, but less than or equal to 5. So we want 0, 1, 2, 3, 4, 5, 6. So I have 2. At 2, I want to shade it in. At 5, I want to also shade in. And my line must connect to circles. I'm including the 2 and the 5 and everything in between. 2y plus 6 over 3, the absolute value, that is, of 2y plus 6 over 3 is equal to 2. The absolute value tells me that when I come out of here now, I have 2y plus 6 divided by 3 is equal to negative 2, or 2y plus 6 divided by 3 is equal to positive 2. Multiplying both sides by 3 to get rid of my denominator here, I get 2y plus 6 is equal to negative 6. Subtracting 6 from both sides, I get 2y is equal to negative 12. Dividing both sides by 2, y is equal to negative 6. Multiplying both sides by 3, we get that 2y plus 6 is equal to positive 6. Subtracting 6 from both sides, we get 2y is equal to 0. Dividing by 2, y is equal to 0. And you must check your solutions to make sure that your values are correct. The absolute value of 6x minus 3 is less than or equal to 9. This tells us that 6x subtract 3, let's do this again. 6x minus 3 lies between -9 and +9. And we want to solve. We're going to add 3 throughout to get rid of that -3 in the center. -9 plus 3 is equal to -6, which is less than or equal to +6x, which is less than or equal to 12. Dividing throughout by 6, we get that -1 is less than or equal to x, which is less than or equal to 2. So we want to now represent on the number line, we have 0, we have -2, -1, 0, 1, 2, 3. Going to -1. Again, we're going to shade in. Go to +2, shade in, and remove from one circle to the other. We have a similar problem, but here now we need to simplify before we get to the absolute value. So first we want to subtract 5 from both sides. When subtracting 5, we now have -2, absolute value of 2, open bracket. Actually, let me expand this bracket while I'm here. 2 times x, giving me 2x. 2 times +2, giving me a +4, which is less than or equal to -1 plus -5, which is -6. Now I want to divide by a negative. In order to divide by a negative, I need to change the direction of my sign. So I now have the absolute value of 2x plus 4 is greater than or equal to -6 divided by -2. The absolute value of 2x plus 4 is greater than or equal to +3. Now, when we have greater than or equal to +3, we now end up with either 2x plus 4 is less than or equal to -3, or 2x plus 4 is greater than or equal to +3. Solving both. So let's do one here. So we have 2x plus 4 is less than or equal to -3. Subtracting 4 from both sides, we have 2x is less than or equal to -7. Dividing both sides by 2, x is less than or equal to -7/2, or x is less than or equal to -3.5. Next, we have 2x plus 4 is greater than or equal to 3. Subtracting 4, we have 2x is greater than or equal to positive. That should be subtracting 4, not plus 4. 2x is greater than or equal to -1. Dividing both sides by 2, x is greater than or equal to -0.5. So now we're going to go to our number line and put in our points. We have, so let's see if we can do this in point. Let's make this -4, -3, -2, -1, and 0. So we have -0.5 right here. And we have -3.5 right there. So we have a circle would go there. Now we want to make sure that we get this right. Now it says that x is less than, let's see, x is greater than or equal to -0.5. Greater than or equal to would go in this direction. Line's not straight, but we get the gist. X is less than or equal to -3.5. Here, same thing. And we're going to go in this direction. A rectangular soccer field is twice as long as its width. If the perimeter of a soccer field is 300 yards, what are the field's dimensions? Problems like this, we want to just draw a sketch of what we're looking at. So we have a rectangle, and we know some things about a rectangle. The opposite sides are equal. You have the width and the length. So this is our length. This is our width. But it says the field is twice as long as it is wide. So we need to use some algebra to solve this. We need to use algebra to solve this. So we're going to take a variable. Let us use W to represent our width. So let W be the width. Now we're going to represent our length in terms of our width. It says that it is twice as long as it is wide. So my length is going to be 2 times the width. So length, my length is 2 times the width, 2W. Now we do know some things about the perimeter. The perimeter of a rectangle is given by the formula 2 times the length plus 2 times the width. So now let's substitute into our formula. We have our perimeter, 2 times the length. Our length is 2W, so 2 times the length plus 2 times the width is equal to our perimeter, which is 300 yards. We can put the yards, so let's leave the yards off for now. So we're now going to solve this equation. 2 times 2W is 4W plus 2 times W, which is 2W, which is equal to 300. 4W plus 2W is going to give us 6W, which is equal to 300. Dividing both sides by the 6, we get that W is equal to 50 yards. So we want the dimensions. So the width is 50 yards. And the length is 2 times W, which is 250, which is equal to 100 yards. So our dimensions, 50 by 100. The sum of 3 consecutive odd integers is 513. The sum of 3 consecutive odd integers is 513. What is the largest of the 3 integers? Now, odd integers, we would have a number, skip a number. So let's look at that. So let's begin by letting x be the first integer. So my second integer would then be x plus 2, because I'm going to skip 1. Okay. And my third one would be x plus 4. So we have our 3 integers. So we have our 3 integers, x, x plus 2, and x plus 4. Now it says that the sum of these 3 odd integers is 513. Sum indicates that it's the result of addition. So we have x plus 2 plus x plus 4 is equal to 513. Simplifying, 1x plus 1x is 2x, 2x plus 1x is 3x. 2 plus 4 is 6, that's positive 6, is equal to 513. Subtracting 6 from both sides, we get that 3x is equal to 507. Dividing both sides by 3, we get that x is equal to 169. But we want the largest integer. You can find all 3 integers and then move from there, or you can just go straight to the largest one, which is the x plus 4. But I'm going to find all of them, all 3 of them. So we have our first integer, our second integer, x plus 2, is going to be equal to 169 plus 2, which is equal to 171. And our third integer, the second, third, 169 plus 4, which is equal to 173. So the largest integer is 173. A triangle has a perimeter of 52 meters. The length of the second side is 7 meters more than the length of the first side. The third side is 5 meters less than twice the first side. How long is each side? Looking at a triangle. Let's have a look. Now, it says the length of the first side, the second side is in terms of the first side, the third side is also in terms of the first side. So let's let first side be x. So we have x. And then it says that the length of the second side is 7 meters more than the length of the first side. So 7 meters more, that'll be x plus 7. And the third side is 5 meters less than twice the first side. Twice first side, and it's 5 meters less than twice. So our three sides are x, x plus 7, and 2x minus 5. You can write this down as well. Second side, third side, or you can just use from the triangle. So we now have our perimeter, which is 52. Now we know that the perimeter of a triangle tells us that we must add all three sides. So adding all three sides, we have x plus x plus 7 plus 2x minus 5 is equal to 52. And that's 52 meters. Collecting our like terms, we now have 1x to 1 plus 1 is 2x plus 2x. 2x plus 2x is 4x. We have positive 7 subtract 5, giving us a positive 2, and that is equal to 52. Subtracting 2 from both sides, we get 4x is equal to 50. Dividing both sides by 4, we have x is equal to 15 divided by 4, which is equal to 12.5. 12.5, and that's meters. So the first side, x is 12.5. Our second side is x plus 7, which is equal to 12.5 plus 7, which is equal to 19.5. And our third side is 2x minus 5, which is equal to 2 times 12.5, subtracting 5. 2 times 12.5 is 25, subtracting 5, which is equal to 20. So each side we have 12.5 meters, 19.5 meters, and 20 meters are three sides.